Welcome to part 2 of our demo series. Here we are logged on to our Azure virtual machine we created in part 1. From here, we're going to just create a text file on a desktop simulating the fact that this is a critical server running applications and housing data that is mission critical for our organization. Important data on a desktop with very important information in it. Okay, back to our Azure portal, we can go to our virtual machine and we can take a look at it and we can see all the aspects of the virtual machine. And we can actually navigate down to a section called Backup. Here's where we can control backups. If we need to back up our virtual machine, we can do that very easily in Azure. First thing we need is a vault. If we don't have an existing vault, we're going to have to create a new one. In this case, I want to create one that's offering a name suggestion called Vault 692. Let's call it something better. Let's call it Demo Vault. Again, everything needs a resource group, so in this case, we're going to put it in our existing resource group, Demo RG. Also, we're going to need to create a backup policy. This is a retention policy. We can create many retention policies, so every virtual machine we back up, we can choose which retention policy we would like to use for that virtual machine. In this case, the default policy is a very simple policy that does a default daily backup, and that backup is maintained for 180 days. This can be customized, or we can create a new policy. Let's just customize this one. Let's keep our daily backups for 30 days. Let's keep our weekly backups on Sundays for 5 weeks. Let's keep our monthly backups on the first Sunday of the month, and let's keep those for 12 months. And let's go ahead and retain our yearly backups on the 1st of January, on the first Sunday of January for 10 years. It can also be day-based, January 1st, or the first Sunday of January. In this case, let's just leave these default settings and click OK. We've now created a retention policy, and we're going to create a vault with this name in this resource group. Now, if we had already created the vault, we wouldn't need to do all these things here in this blade. If we had this vault already created, we can easily just attach this VM to the vault, or even we can do it from the vault. We can go into the vault and we can say, I want to protect an Azure VM and select the VM from there as well. Again, as mentioned earlier, there are many ways to do the same tasks in Azure. In addition to all the different ways in the portal you can do a task, you can also do all of these tasks from PowerShell and a lot of different types of tasks from Visual Studio programmatically. There are many, many ways to do things in Azure. It's a very open platform. In the meantime, while this is happening, we're also going to set up disaster recovery on this virtual machine. The concept of disaster recovery is that we want to be able to survive a regional outage within the Azure region where our virtual machine is running, whether it is a Microsoft issue, some other type of man-made issue or natural disaster that affects that Azure region and potentially affects the availability of our virtual machines in that region. If we're running virtual machines in an Azure region, we need to understand that there is no 100% SLA in any public cloud that's going to guarantee that nothing will happen in that region and your VM will always be on 100% of the time. So to work around this, Microsoft has offered functionality on the platform known as Azure Site Recovery, which allows you to replicate your virtual machines between regions. This is the same tool that's used for disaster recovery as a service to protect your virtual machines from your data center into Azure on an ongoing basis. Azure Site Recovery supports replication of virtual machines from VMware, physical servers, and Hyper-V. Azure Site Recovery also allows you to protect virtual machines running in one Azure region to another. Azure Site Recovery is often known as the Swiss Army knife of BCDR because it is a very flexible tool. Our deployment succeeded, as you can see, and if we go to our vault, which we probably won't see here, but if we go to all services and we choose recovery service vaults, we will see one that we just created called Demo Vault. And if we go into it, we will see an overview screen where we can look at backup, and we can see that there is one backup item in this vault, and it happens to be an Azure virtual machine. As you can see, there are other types of things you can back up. You can do SQL backups, Azure storage backups, and other types of backups, also from on-premise as well. In this case, we have an Azure virtual machine. And we can see that there's a warning message saying that the initial backup has not taken place. And part of our retention policy was that the backups would take place once a day in the evening. And in this case, if we wanted to do it now, we can initiate it now, or we can wait until tonight, and then it should work. If we forgot the settings, we can always go back into our backup policy, and we can see the settings or create new policies. In this case, we have a default policy that we used, and we can click on that default policy, and we can see, actually, it was the daily policy, not the default policy. All the settings that we had chosen, and if we click associated items, we can actually see that that one VM is associated with this policy, and that the backup is indeed going to take place at 5 p.m. If we want to change that now, we can change that here, and we can say, no, we want it to take place at 10:30 p.m. instead, and we can save that change. This shows you some of the flexibility in Azure. What we're going to do now is we're going to demonstrate how we can replicate this from one region to another. So if we're running in Azure East US, which is in Virginia, and we want to protect this VM and replicate it to another distant region, we can choose a partner region that we want to replicate to. We are not bound by any limitations. We could replicate this to any region we would like. In this case, let's go ahead and replicate it to the West Coast of the United States. The first thing we're going to do is we're going to go to the VM, and we're going to click on disaster recovery. Again, backup and disaster recovery are two different things. The backup is taking a daily snapshot of the VM and keeping it based on a retention policy, allowing us to restore either the entire virtual machine on top of the original, the entire virtual machine to a new VM instance, and potentially another network not connected to the original, or lastly, just item level restores where we can mount the disks and pull whatever files we need and dismount them. Azure Backup is very flexible, but all of those backup restores are happening in the same region, and they are not meant for any type of BCDR strategy, but more they are meant for a backup and retention strategy. In this case, we're going to go in the disaster recovery tab, and we're going to see a few options here. So the target region is already defaulting to the West US, and you can see here it actually has a nice graphic showing us where our source VMs are replicating from and to. In this case, from the East Coast of the US to the West Coast of the US. This looks good to me. We're going to choose the same subscription that we're working in. We're going to need a new resource group on the other side for the VM as it's replicated and brought up in the West Coast. So in this case, we're going to let it create using the default naming convention, which would be the resource group that lives in the East with a -ASR at the end. Availability set is not an option because it's not in an availability set in its primary location. If it was, then we would have the option to fail it over into an availability set in a DR site. And the virtual network will have to be created as well. Again, if we had a virtual network existing already in the West Coast region, then we can choose that virtual network, but in this case we don't. So we're going to let it create a brand new virtual network on the West Coast using the name of the virtual network in the East with the -ASR at the end. There are additional settings we can configure, such as the storage account settings, replication settings, and any other extension settings. These settings are out of scope from this demonstration, and we're just going to enable replication now. It should be known that the failover region has several different concepts and methods that different companies use to do these types of failovers. A commonly done method would be a method where you would have a living, functioning, connected virtual network in a failover region that would be connected to your on-prem data center, just like your primary region, that would be routable, that would contain domain controllers and any other infrastructure servers, and it would be an active directory site with an active IP space that is routable and configured to be connected to from any of your locations. That way, if you fail over your application servers, they are coming up in a live site. They're obviously going to get different IP addresses when they come up. They can register in Active Directory DNS and be accessible from your clients after a failover has occurred. There are other options and other methods used by different companies where they would fail over to the same IP space that obviously couldn't be connected simultaneously if they're sharing the same space, but this is also done for companies that prefer that method. In this case, we're going to let this thing cook, and we're going to let it marinate, and we're going to review and pause this demo and wait till the replication has occurred, and then we can demonstrate a failover. Okay, we're going to go ahead and resume our recording. Replication has finished. The virtual machine took about 2 hours to replicate. So if we go and look in the vault now on the West Coast, we're going to see, if we click on Site Recovery, that we have one healthy replicated item. And if we click on that, it's going to show us our VM, Devo VM1, which was misspelled in the first place. It should have been demo. But since we didn't catch it, we're going to keep the name Devo because we like Devo. Anyway, when we click on the VM, you can see some stats about the replication. This is ongoing continuous replication. As you can see, the current RPO, or recovery point objective, is 2 minutes. So that means if we do a failover right now, we would potentially lose only the last 2 minutes worth of data. Now that's for a crash consistent recovery point. There's also something called an app consistent recovery point. And if we were going to fail back to our app consistent recovery point, we would actually have a larger RPO. In this case, it looks like it's about an hour ago. App recovery points can run as frequently as once an hour, and that is a recovery point where the Windows VSS writer would be invoked and take an application consistent snapshot that would allow consistency for database applications. But if it's a stagnant or application server, then typically a crash consistent snapshot is perfectly fine if there is no transactions being written. In this case, we can see our RPO is 2 minutes. We can still see our graphic that we're replicating it from Azure East to Azure West. And now at this point, we can see that the last successful test failover says it's never been performed. So why don't we go ahead and try to do a test failover. Before we do that, let's just take a look at some of the settings. So we see the stats here. We can go to the compute and network settings. We can go ahead and take a look at some things that we can configure if we wanted to, or we can leave things the way we already have them configured. So we have a source resource group, which obviously we can't change. However, we have a target resource group, which we chose earlier, but if we change our mind, we can put it somewhere else. Additionally, the size, it is using the same exact size as the VM in the source location for the destination, but obviously we can change that to be bigger or smaller or anything in between. From a networking perspective, currently we have not statically assigned an IP address. We're just using a dynamic assignment. But if we need it to be statically assigned, we can go in here and we can statically assign the address by typing it in here, and we can also choose which subnet we're going to land this VM in once it fails over. Again, in this case, we just replicated our virtual network from Azure East US 2 to Azure West US. But in a real scenario, you probably would have a pre-staged virtual network that may or may not have different subnets depending on your configuration. But in this case, these virtual network settings and IP spaces are identical because we just had it automatically create the same virtual network for the to make things faster. So we're not going to change any of this. And lastly, we can take a look at disks, and this is interesting. So we can see that our OS disk here is the only disk. There's no data disks, but if this VM did have data disks, we would have the option to protect all the disks. So not just the C drive, but other disks as well, where we might have applications or other data installed. So at this point, we're going to go back to the overview page, and we are going to perform a test failover. So you'll notice on the top here that there are a few options, one being failover and the other being test failover. So they are self-explanatory. The failover is intended to be used only for actual real failover drills where there's an actual incident where you want to fail over the VM, shut down the source VM, and then have the opportunity to reverse replication in the other direction so that once your disaster has been recovered, you can potentially fail back the virtual machine to where it came from. In the case of testing, which is most often what you'll be doing, then you'll be using a test failover. So a test failover is a non-intrusive function that will not stop replication from occurring versus the failover. If you do a failover, you will no longer replicate once you commit your failover. Whereas the test failover, you will bring up the VM in the target location and all the time be continuously replicating the VM and protecting the VM while you're conducting your test for as many days and weeks as you'd like to have it running. The replication will never stop. So if we choose test failover, we're going to be prompted with a question. Now you saw earlier on the configuration settings, we had a target network and subnet that we wanted to bring this VM up in a failover. In a test failover, Microsoft assumes that we might not want this to be intrusive testing, and if we have a connected network, as we described earlier, where we're routing back to on-premise maybe, this might be a domain joined server, and if it comes up in another subnet while it's still running in the source subnet, that can cause problems in Active Directory, and we certainly don't want to have two VMs running that are the same VM in different locations. So in that case, we typically would want to do a test failover to an isolated network or do a staged failover drill where we might be shutting down a source VM and bringing it up in a target network. So it would be a quasi DR drill where we are shutting down some infrastructure to do actual testing. All of this depends on your environment and can be highly customized. In this case, we don't have many options. We're actually just going to select our virtual network, which is the only one we have in West. As you can see, Microsoft Azure is warning me that it is recommended that for a test failover, you use a network different from your production network, as specified under the compute and network settings. But we discussed that and we decided that we're going to do this. We're not connected to anything and there's no Active Directory involved here. This is purely for demo, so we're okay with this. And of course, there are cases where we do these types of tests for customers in their environments. For instance, non-domain joined servers. It's not really a big deal if we're doing this type of test for DMZ servers and web servers and things like that. So there are a lot of cases when we might do this for real in an actual environment for a test DR drill. We also have options of recovery points. In this case, we're just going to choose the latest processed recovery point with the lowest RTO. But you can see that there are options for the latest app consistent. If this was a database server, we might want to choose that, or custom. And custom would show us as many snapshots as we have available over the last, in this case, 24 hours, but it can go as high as 72 hours. In this case, we're just going to choose, whoops. In this case, we're just going to choose the latest recovery point. And we're going to click OK and kick this off. Okay, took a minute there, but now it's going. Again, we see the progress here in our alerts section, and we can click on the job and see some specifics. Nothing there yet. We have to wait a minute. We're a little bit premature there, but if we go back in here and see the starting of the job, we should see some information populating here. Okay, the portal sometimes is a bit behind, so the job has started, so we can just go ahead and wait, and it should start populating shortly. Again, we're going to pause this demonstration and come back when this has completed. Okay, we're back. So our VM has failed over successfully, and as we can see on the test failover job details, the total duration of the job started at 2:59 and 50 seconds PM and completed at 3:03 and 9 seconds PM. So we're talking about 3 minutes and change for the failover to occur. Imagine if this was a mission critical line of business application running in a site being replicated to a DR site, and in less than 5 minutes, I can bring that server up or a group of servers up with a less than 5 minute RPO. That's impressive. So now, if we go back to our virtual machine view, we're going to see the initial VM and the failed over VM with the -test at the end, indicating this is from a test failover. If this had been a real failover, then the VM name is going to be identical without the -test. So it is very easy to know whether this VM was from a test failover or an actual failover. In this case, it's a test failover. And if we click it, we could see that it's actually running. So as you can see, our VM is running and we have our typical VM blade. We did have to manually add a public IP address because that is not part of the failover process and would have to be added as an extra step. In this case, we just added it manually, but it all could be scripted and part of a recovery plan that utilizes automation scripts to do things like that. In this case, we just added the public IP address and opened up the port on a new NSG. That said, we can now connect to our VM. Going to log in with our same credentials from the other side, from the source VM side, onto the target VM, or the replicated VM, we should say. And here's our important data, just to prove that this is the same VM. Okay, so we did a crash consistent snapshot, which means we replicate our disks real time on block level changes. And in this case, we just turned the server on from a point in time. And that is why Windows thinks that it shut down, because it actually did shut down. It was brought up from a dormant state from a replicated disk. In this case, we will just cancel that message, check our file, and here is our super critical and important data. This demonstrates Azure Site Recovery. We will now log out of the VM. Of course, this VM could be 10 VMs, 20 VMs, or 50 VMs. In the recovery plan, you can specify the order of operations, where each VM will be brought up as part of a group in a specific order, for instance, where potentially database servers would come up prior to application servers, or even other servers, domain controller servers, etc., can all be staged to be brought up in a very specific order. In between, you can run automation scripts that would do all kinds of things like opening up ports or adding VMs to load balancers. At this point, we are completing our test, so we're going to go back to our dashboard where we can easily get back to our vault in the West Coast. We can go back to under recovery. As you can see, we're in the middle of a test failover. We can go to the VM and we can see the stats. They tell us that the RPO is currently 17 seconds. As you can see, the test failover not interfering at all with the continuous replication of this VM. At this point, we have completed our test and we are happy with the results. We're going to click Clean Up. We can put notes in here if we want. And we're going to say testing is complete, delete the test failover virtual machine. And that could be plural. If there are multiple virtual machines in this test, then we can delete them all at the same time, and that includes deleting all of this associated along with the virtual machines, such as disk and network interface cards. This concludes our Azure Site Recovery demo.